P.2quared journal, entry 10, Helix constituents. So today in the journal entry, I want to start talking about one of my basic paradigms that's different from the way that most people think of the subatomic universe. So I like to keep it in realms that I can understand. So when I started learning about quantum theory, I had a problem because it was so chaotic. There were so many emergent things that came out of our understanding of the quantum mechanical model. And so I wanted to come up with a model that was less chaotic and just slightly more structured. And as I thought about the electron and the electron orbit, I got the idea that maybe the charge between the subatomic particles in the nucleus of the atom and the electron itself, maybe that charge was actually particles instead of just a interactive field. So I began to look at both subatomic particles, quarks, leptons, and such, and the charge force between them is all one constituent of matter that is in the shape of a helix. So just to draw it out, every subatomic particle, in my point of view, is made up of a constituent that is in the shape of a helix. This is a hypothesis that I very much would like to test and prove as I go through my college and university experience. If this hypothesis is anywhere close to correct, then it would change the way we look at a lot of things. Because this particle can allow you in a more Newtonian classical mechanical fashion to think of the universe in a way that it can be engineered a lot easier than we're currently trying to engineer forces that we don't have a firm grasp on. This particle also gives you an excellent explanation for gravity and light and why they act the way they do and why they are formed the way they are around matter. So if you look at the way a helix would interact, we'll just make a little particle right here, and we'll assume that this particle is a cluster of these helices. So while the circle just shows the boundaries of what we're considering, in reality it is a cluster of hundreds of thousands or maybe even millions of these helices, and the particle's characteristics are determined by the dynamics that the helices have in relation to each other. So the more energy in a system, the more likely it is to be negative. If you consider its energy relative to its number of constituents, the number of helix particles that you have inside of it. But the greater the amount of those helix particles, the greater the chances that the particle will be a positive particle instead of a negative particle. And then the ultimate determining factor is if a helix particle comes out of the cluster that it was a part of and gets clipped on the way out, then it will be given a spin. So it's not only traveling this way, but it also has a spin this way. So it would be here, and then if you take a snapshot of it in a different period of time, then it would be facing this direction, right? with a spin and a pull that would be going a different direction than it initially had. So this bit of theory it's not theory, I'm sorry. This hypothesis is a very interesting one to me, because if it proves to have any grounding in reality, it will completely change the way we look at subatomic particles, and it will completely change the way we look at the universe. In the next few days, I'm going to go over it in more detail. It's a difficult to explain theory at this point in my ability to communicate. But over the next few days, I'm going to be breaking down different aspects of this theory. This is probably one of the most important things that I can contribute to the sciences if it has any grounding in reality. And even if it doesn't, it could lead us down a path that would help us to understand the most minute aspects of the universe far better. So today, it was just an introduction. In the following entries, I want to put in video what I've already put in writing in entries 1 through 7 about this theory. And once again, not theory, but hypothesis. I'm sorry, I use the word theory way too much. But what I'm going to be doing is I'm going to be taking pieces of the what I'll call preprint paper that I am currently working on, and I will read the statement in the paper and then explain it with pictures on the screen like this, and also be giving a more detailed explanation of what the paper is trying to say. So stay tuned. It's gonna get springy. We're gonna have a lot to go over in the next few entries.